Hello, I'm back. Davidson here with our 2017 GSX-R1000. Now, when we left off last time in our exhaust installation in theory, we were on part 2. We're now on part 3, where we're going to get into full systems. And full systems can get they can get a little bit technical. They can get a little bit confusing. I'm going to try to cover the span between people who don't know much and people who know a lot, and let you understand what we're trying to do here. So what we proved last time basically was, as far as slip-ons go, they're great for a look, sound, they're easy, and they're economical. Well, it's time for us to get serious. We're going to make this bike run. And when I say that, to turn it into a performance machine, you really have to pay attention to details and do your homework. And what you see here, you'll see some exhausts that we've created. You don't see the testing that goes into those exhausts, and I'll explain that to you here in a minute. When we get over to the bench, I'll show you, give you some examples. But anyway, what we're doing, we're going to take this bike to the drag strip. We may take it land speed racing, and of course, there's a chance it could be seen on one of our roads around here. So, to make it as fast as possible without getting into the engine, we're going to concentrate on bolt-on parts and really combinations. You know, I'd love to tell you bolt on our full exhaust and you're going to be the fastest bike in the world. Yeah, well, if you've ever raced or you know anyone who raced, the devil's in the details. You know, does the intake system function correctly with the exhaust? Is the bike tuned properly? Now, this is a whole lot of things that we get into that a lot of the other manufacturers don't. They make a pipe, they put it in a box, they ship it to you, and they hope you know what to do with it. We do things a little differently at Brock's Performance. We provide fuel injection mapping. We provide technical support. If you buy the fanciest exhaust from a, let's say a Slovenian company, call them up and ask them what the best gearing you're going to need for the most acceleration possible in the quarter mile or in land speed. That's not what they do, right? And we have plenty of guys that go road racing too. We just, our main focus, and especially with this bike, we're going to concentrate on drag racing because the drag strip is a tool that we use to measure acceleration. And the harder this bike accelerates, the faster it is. It's just really that simple. So we're going to concentrate from the exhaust standpoint, what drag racers really care about. I call them the 3 L's of drag racing: longer, lower, and lighter. If the bike's longer, it's not going to wheelie. If the bike's lower, it's not going to wheelie as much. If the bike's lighter, it's going to accelerate quicker. If you're not going to stretch your bike, then don't worry about that part. We're still going to boost the performance and make the motorcycle lighter and accelerate harder. So you take weight off of the exhaust, the bike's more flickable, it's more controllable. There's all kinds of things that go into this besides just I bought a full system for my bike. So we're going to get down into the nitty-gritty right now. I'm going to take you over here to the bench and just sort of show you a couple things that we found out since our last episode. And we'll do that right now. So guess what we're doing? That's right, we have an endoscope. I'll let you see. So when we were pulling this lever, we thought it was closing off the crossovers. It's actually opening the crossovers. This is part of another valve configuration here in the SET, Suzuki Exhaust Tuning. So, why is this relevant? Well, we got it wrong. Good news is, we've got an idea exactly what they're doing here, and I'll explain it to you. This bike has very small diameter head pipes. Small diameter head pipes are great for low end torque, they're great for mid-range, but they typically hurt peak power. So what it looks like they've done is take some much larger crossovers, connect cylinders number 1 and 4 together, and then this valve connects cylinder number 2 and 3 together. And then at high RPM, the ECU yanks this lever, opens this valve, and allows the exhaust gases from cylinder 1 to not only flow out of its exhaust pipe, but also out of cylinder number 4, and vice versa. 4 can also grab from 1. It amazes me how smart these guys are. When we were talking about crossovers previously, this is an exhaust. This is an example of an exhaust with your standard crossover. You'll usually have a tube connecting cylinders number 2 and 3. Sometimes you'll have 1 and 4. It just depends on the manufacturer. Well, I can tell you this from past experience. If I take this exhaust and I build just an aluminum plug and plug this tube, the bike will pick up more peak power. So they're doing opposite things. They're just doing them in a different style configuration. So what does this matter to us? Well, first of all, I'm man enough to admit we had a little bit of a mistake there. That we had to dive into it a little bit deeper than I thought, but it's pretty smart stuff. So the real question is with all these goodies and all the things that are going on, can we outperform this exhaust? That's really it. That's really what we care about. So let's start talking about what performance really is, and how we go about it. Weight. First off, this thing is heavy. There we go. 15 pounds just for the front section. Add the muffler. 23 pounds. Well, I can tell you we can definitely do better than that. So you lose some weight, pick up acceleration. That's a step in the right direction. Let me get some other things configured here, and I'll get a little more detailed about what all these tubes do in a full system, and so we can sort of see what we're doing and see whether or not we can truly outperform this exhaust. I've placed our 2017 GSX-R1000 Predator exhaust on the scale here if you want to take a look. Now this is our full titanium version. 8¼ pounds versus 23 pounds. So that's about a 65% weight savings. Just in changing the material and changing some of the design. Of course, we don't have a cat in this pipe. This is more of a standard pipe. We don't have any crossover tubes. Titanium muffler. Now there are some stainless pieces on here. The end cap stainless, the core stainless. And that's for longevity. And one of the things I wanted to mention, there are some exhausts you can purchase on the market these days, especially titanium exhausts, where they say don't use your traction control in certain modes, and also if you've changed your tire diameter. And man, that's really confusing. We just build our stuff to take the heat, and we did this with our Predator. We also did it with our Alien head. But let me get this thing off the scale, and we'll do a little comparing here. What does it take to make an exhaust? Well, you can see the OEM configuration, head pipes 1 and 2 go into a collector, and then 3 and 4 tied together go into another collector, and then they come into this Y pipe. Well, our Predator exhaust, they're more geared towards road racing. So what do we want in road racing? We want good power. We want good power, partial throttle power. So when it comes to configuring that, we have different diameters here. Now this diameter is, if you go over here to the stock system, we've got 1.5" head pipes all the way down. There's no steps. You come over here to our Predator, it's inch 1.625, so 1 5/8" head pipes. They are tapered from up here, where we actually choke them down under 1.5 inches. Now that gives us sort of a megaphone effect here. And then we've got a step here in the tubing. We come down here and look at this. Cylinder number 1 and 4 are tied together on our Predator, and 2 and 3 are tied together in the same collector. That's to produce more torque. I mean, that's what it's there for. That's what it's designed for. When you're coming out of a corner, you need as much as you can get. Like I said, partial throttle operation. This configure has shown to work very, very well without hurting peak power. Now, the second thing we look at, well, we look at head pipe diameters. We look at head pipe lengths. So, as a general rule, we have certain lengths that we know work well. Head pipe length on this Predator is about 21 inches. You go over here to the stock one. Head pipe length is 17.5. So there's a considerable difference in length in the head pipes between the OEM system and the Predator system. And then you start looking at the collector. And one of the things that you can do with the collector, by changing this length here, it can have a dramatic effect on mid-range power. So in this configuration here, you can see it's slightly different. Each cylinder is running through a tube that helps pick up velocity, and then it comes back down, and then it goes out to a tapered elbow, which is similar to a megaphone, but of course it'll be attached to our muffler here. So, and whereas this system doesn't do the same thing. They have a larger volume here. They've got the cat. Now, some of these larger volume cats work out very well also. You'd be surprised. It's not easy to just beat what these guys have. But that's our job. And this particular pipe is being used with experience from, World Superbike experience, a lot of road racing experience. And this configuration works very well for some very, very fast road race bikes. So that's why we wanted to start this way with this new GSX-R. Now, with the ECU restrictions in place, we would have something different. But we know that we're going to have the ECU restrictions out of place, and then we'll also test it, with the restrictions in, just to see if we can beat this pipe here. So anyway, that's just it, sort of in a nutshell. The one other thing I might want to mention: the stock exhaust has a sensor in it. Now, there's a lot of confusion about what these sensors do. And I can tell you what they do. A narrow band sensor is only good for it. Let's say this is set at 14.7 to 1. It only knows if it's not 14.7 to 1. So the ECU says, okay, we don't have enough fuel, we need to give more fuel. And if this is set at, let's say, 16 to 1, if it wants to be 16 to 1, it'll take fuel away. These are only for emissions. This is an emissions tool, that's all. You can leave it in your bike and think that your bike is tuning itself. It is only for emissions. So it's taking the ratio of air fuel that you're using, and it's leaning it down at cruising speeds only. At wide open throttle, this isn't even on. This is only for cruising speeds. It's only for emissions. Now, we have customers that are very, that care about the environment. They want to run these, and they want to run them with their stock ECU. That's not a problem. We have conversion bungs here, and then we also have a little extension cable that allows you to run it. If you're racing, this needs to be removed, and your ECU needs to be adjusted so that you don't get check FI lights when you remove this, and also the little servo box on the back of in the back tail section that turns all this. We can turn all that off with a flash. So the next thing I'm going to get to is important. Lower, right? If we're going road racing, we don't really need to care about how much ground clearance the bike has. But if we're going to go drag racing or land speed racing,
Hello.
We don't want the pipe to hang way down. We want to try and tuck it up as much as it can. Now, we're only dealing with so much room here, and this GSX-R is tight. It is a super tight installation. But as a general rule, for every inch you lower your bike at the drag strip, you pick up about 1/10 of a second in the quarter mile. And it depends on how difficult the bike is. On a short wheelbase bike like this that makes a lot of power, it's more than 1/10 of an inch per second. So keep that in mind. And that's the, I'll get into the differences between our Predator systems and our Alien Head systems. The Alien Head system is, we know what guys are doing with that. They are drag racing. So we build additional clearance in. It's also very light, but we also do some different things with the head pipes. And I'm going to go ahead for demonstration purposes and pull the pipe off of this bike just so we can compare the two, so you can see exactly what we're doing, the differences between the Alien Head and the Predator for different applications. So I'm going to take off that pipe and we'll be right back. Here we have our 2017 GSX-R1000 Alien Head 2 exhaust. Now, we just pulled this off the bike. You can see it's discolored a little bit. That's normal. Now, when we go with the titanium exhaust, they're going to turn really neat colors, blues, purples, depending on how hot the intersections are or the mufflers are. So, one of the things we do here is, we're a performance company, but we realize that the pipes have to look good and they have to sound good. So, I did want to mention also in the Predator. The Predator comes with a Euro style approved tip. Now, when you get the pipe, it's installed and you may like the sound, but I can tell you, this is a horsepower killer. It does a great job of dampening the sound levels, but it does an equally good job of removing peak power from your bike. So if you're really conscious about your performance, this is not something that you're going to want to go to the racetrack with or to a dyno shootout. That's just not what it's made for. It's made so that you can quietly ride your motorcycle around without teeing off your neighbors. Back to our Alien Head. Stainless steel, 9.3 pounds. Now, if this is made out of stainless steel and this is made out of stainless steel, how can this be so much lighter? Well, we use an ultra thin wall stainless. It's not very easy to work with. It's a little bit of a pain, and I'll show you this right here. When you look at the welds on a system like this system has to be MIG welded, which is a wire weld. Otherwise, it just burns through this ultra thin stainless. So we'll get people say every once in a while, well, the welds on your Alien Head aren't as pretty as the welds on your Predator, which are gorgeous. This is a TIG weld. And the same thing, the welds on our CT exhausts are just absolutely gorgeous too. Well, it's because of the manufacturing process. No one would be able to afford these if we took the time to TIG weld them all. So to keep them economical, this is a considerably less expensive exhaust than this. But from a performance standpoint, this thing is something else. Now, when you get your Alien Head, you get a big hole. There's nothing in the way. These pipes are designed to move air. If you look at the construction, we've gone with the same configuration as Suzuki has with cylinders number 1 and 2 into a merge style collector as opposed to a tube style collector. And then when you look at the diameter, we're at 1 3/4 diameter. These are big pipes. So, and then you come over here to the collector. You can see the collector short, 2 inches. It's a short pipe, big collectors, big head pipes. These things are designed to move air. And what we really try to do with the design of all of our Alien Head exhausts is to anticipate, okay, how many guys are maybe going to add nitrous oxide? Well, if you add nitrous oxide, the density of the gas that you're going to be trying to push through these valves these pipes becomes very, very high. So having a larger diameter pipe works better for nitrous applications. these exhausts also work great if you decide to do engine work. If you rev the bike higher with, you know, in your ECU, larger diameter, shorter head pipes. I just measured these here a minute ago. We'll do it again. Yeah, we're looking at a little over 17. So short head pipe, we're looking for peak power on these things. We really want peak power. And you know, we can build an exhaust that has very small head pipes, like stock, designed for partial throttle openings. Problem is that it just hurts peak power. So since we're not concerning about that, we're thinking about the guys that are on the racetracks, on the roads, doing whatever they need to do, 9/10 mile, whatever. You don't start off your race by saying, okay, I'll be at half throttle, you be at half throttle too. No, it's not how it works. We know that. This pipe is designed to make power, accelerate. Now, if we wanted to change the pipe to pick up the mid-range torque, let's say, we could do that, but it's gonna hurt the peak power. Why? Just go up one tooth on your rear sprocket, or if you really want to make a change, drop one tooth on your front sprocket. It makes all of this fine-tuning of these exhausts really seem silly. So that's why it makes more sense to us to really concentrate on the peak power. We can change our gearing for the mid-range. We can change our gearing to help the bike stay on the ground. And you know, quite frankly, when you're drag racing, having a bunch of mid-range power, all it really does is makes the bike want to wheelie. So these pipes are designed for different applications. Can you go drag racing with this? Yes, most definitely. Can you go road racing with this? Yes, most definitely. But they are at home for what they were constructed for. And one thing I'll mention on the oversized pipes, you know, we'll have guys, you know, experts say, you know, Brock, your head pipes are too big. Well, I'll disagree with you. You know, those are the size head pipes that should be on a Buso or a 14. Well, let me tell you something that we've learned. All this pipe testing and development and all the theory and everything that we've put into this really doesn't matter. What matters is, how does that bike accelerate? How does it run at the drag strip? Is it fast? Because that's the tool we're using. And what's not happening on the dyno? It's a static application, which means the bike's not moving. We're getting air in and we're getting air out, but we're not forcing air in. We're forcing air in at the drag strip. So we know we can get away with this larger diameter tubing even on that smaller engine bike. And you know, have guys argue, well, you don't make positive pressure until 150 or 160 miles an hour or whatever it happens to be on that particular bike. True. We're not worried about positive pressure. What we're worried about is the pressure in your intake less negative? So just do yourself a favor and think simply like I do. Put your hand out the car window at 60 miles an hour. That's about the same amount of area as most ram air ducts. Feel that pressure. That's what's forcing air into your airbox. So while it may not have positive pressure, it certainly has less negative pressure, which means during the overlap of the cams, when everything's open, not only are you getting more pressure into the airbox, but it's also helping exit the exhaust using that same force and that same theory. So that, like I said, can get a little bit confusing because we've created pipes that make excellent power on the dyno, but then we take them to the track and they don't run. Well, I'm not interested. We're not in the selling exhausts that don't work well business. Another thing too with these big head pipes, you know, you put them on your bike, and if you don't have it mapped, and this is back to those combination things, if you don't have it mapped, these bikes, they run poorly. Their off idle response is no good. They'll jerk around. I mean, you really need a map to smooth things up. So that's where you start getting into the other guys, right? And picture for me, if you will, a giant company that has pipes stacked to the ceiling in boxes in warehouses and semi-trucks waiting to take those pipes wherever. Are they going to build you an exhaust system that as soon as you put it on, your bike doesn't run right? No, that's not what they do. They build an exhaust that you can put on. If you don't want to map it, don't map it. If you know, it'll run fine 9 out of 10 times, because they're not really trying to move more air. They're not really trying to make more power. Now they have pipes like that. They just use them on their race teams. You can't buy them. So we use what we sell. This exact exhaust pipe is no different than what you're going to get off of our shelves, and no different than we're going to put on this bike and make it really haul ass. So hopefully that covered some of them. There's more. You can get into sound engineering. You can get into all kinds of things when it comes to exhaust systems. We care about performance. We care about looks. We care about weight. And one other thing to consider, you know, we were talking about don't use your traction control on your brand new motorcycle because it'll burn up a pipe. That's just ridiculous to me. This muffler for this alien head has the exact same baffle packing in it as our Ninja H2. This thing will glow so red you could swear you can look through it and not burn up. Use your traction control all you want with our products. We build our pipes to take it. We're not going to ask you not to use how your bike was designed to run our products. So anyway, and that actually makes this muffler about a pound heavier. Okay, we're at 9 pounds. We'll give that up for you not to have to deal with warranty problems or problems with your bike changing tone or whatever could go on when you blow it up using your traction control with the other guy's stuff. I think that's it. We're going to put this pipe back on the dyno, or on the bike. We're going to get on the dyno, and we're going to show you some real results. Because, like I said before, all it really boils down to is, can we beat this while sounding better, looking better, and genuinely picking up the performance of this motorcycle, whether it be on the dyno and then on the track. So bear with us. It takes a minute to put this thing back on, but we'll do that. We'll get you some numbers. So we showed you what kind of advantage we have in the weight department. I think we've got the looks and sound covered pretty well. So why don't we check out the performance? Now, we're not going to bother you. This video is already running longer than we had planned. We're not going to bother you with a bunch of base runs, showing you stock runs again. So what I did, I just decided to pick the best stock ECU stock run that we've done. And that was out of episode 4, part 2. So if you want to come over here and check this out, if you remember, we had Luke's bike here, and we made 166.7 horsepower on that day. For whatever reason, this bike always makes 164, 165. It made 166, so we're going to use that for our comparison now. We're going to come over here, and what we had done, stock ECU, and that's all that's been added. Let me straighten things up here a little bit. Just now, same fuel. Yes, we have a power commander on the bike, but it doesn't have any tuning. It's got a 0 map in it. The red line is with the alien head exhaust. Man, power commander, I'm gonna have to talk to these guys. Dyno makes it tough to read these. But check this out. Look at this gain. The blue line is stock. The red line is stock with the addition of our alien head, and that's all. No tuning, no air filter, nothing. And this is as A-B as we can make by adding the exhaust. You can see at no point does the stock exhaust outperform our exhaust anywhere up the curve. If we go ahead and look at power, let's pick, 8,000 RPM. From 110 up to 123. Now, this is where they're supposed to, the stock exhaust, which we love. You know, that's a great exhaust. We're definitely not bad-mouthing anything. But the part where they're working so hard to increase their performance, through the mid-range especially, look at that gain we've got. Of course, we're not restricted like they are. They are handcuffed. They did a great job with this exhaust. But if you keep going up the curve, you can look even as the throttle blades start to close. If I come over here to 14,000 RPM, 150 versus 161. We're still gapping the stock exhaust. So from a performance standpoint, I think we're doing pretty well. Now, why don't we go ahead and add a flashed ECU into the equation? Now when we look, once again, tighten this up a little bit. Look at this. Now look at the gaps we're talking about here. At, from 155 stock to 164 adding the pipe. Now with the flashed ECU and the exhaust, 189 horsepower. The gains up in here are just absolutely fantastic. So, I mean, we're looking at, what, a 34 horsepower gain? And pretty much no matter where we look, even as you get into the higher RPMs, when it comes to performance, 14,000 RPM, stock, 150 horsepower this thing noses off to, we're still carrying 184 with the flashed ECU. And once again, the flashed ECU has zero tuning. All we did was de-restrict it. We're trying to be as straight up, equal, apples to apples as we can possibly be. It does have a power commander, but no map in it. So flashed ECU, just adding the exhaust, we've got a horsepower gain with the exhaust and ECU of around 34 horsepower, all up here in the top where we want it from a racing standpoint. Now, this bike has the break-in oil in it. We still haven't changed the oil. We don't know exactly how many miles it has on it because it doesn't register them, but looking at other comparative bikes that we've done, we figure we've got about 100 miles on it. So, when it comes to that, certainly the engine's still a little bit tight. And then we can also look at some of the other items that haven't happened. I mean, we haven't put any oil additive in it. We haven't changed the air cleaner. We haven't done any tuning. So look at this. When you look at the tuning here, the bike in its stock condition, and I apologize, this is really difficult to read, but we're looking at an air-fuel ratio of 11.7. Now we've raised it all the way up to 14.8, but you can see it's all over the place. So it's lean here, it's rich here, we've got bumps in it, and that's where we're going to go to next. It's part of the combinations we were talking about. The stock exhaust matched the stock configuration very well. For a stock bike, this thing runs great. But now we've changed the exhaust. So we want to make the exhaust and the engine both work together in harmony. And you do that with tuning. We're going to go ahead and do it with a power commander first and show you what that takes. And then we're going to play around with some of the ECU tuning also just to give you some ideas. But that'll be coming up next. That'll be part 5. And until then, I'm Brock Davidson, Brock's Performance. I'll see you then.